Hi Jay and anyone else watching. Yeah, I know these ones. He's called it special manipulation. Yeah, I've heard it called algebraic tricks before or something like that. But yeah, there's nothing to it really. Basically, right, let's look at this first one. The trick is, wouldn't it be nice if that was x minus 1 on top? So I'm going to write it as x minus 1. But then I'm going to put plus 2, so it's still the same as x plus 1. I'm going to put that all over x minus 1. Yeah. Okay, but that means I can split it into two parts. I can have it as x minus 1 over x minus 1 plus 2 over x minus 1 dx. And that is obviously 1. So I'm really integrating 1 plus 2 over x minus 1. And now I'm good. Now I normally do that in almost one line. I normally rewrite that like that. And then I go straight to this line here because I think that divided by that is 1. And this divided by this is this. But now I can obviously integrate it, giving me x plus... Think of the 2 flying out the integral, you have 2 ln x minus 1. Strictly speaking, it should be in a modulus, just like they've written it, and now just put plus c. That's how it works. Let's take the bottom one, because the bottom one's a little bit harder, yeah? Slightly harder, yeah? Because the idea is, when you've got something like this, 2x minus 3 over x plus 2, we want something which is going to divide x plus 2 nicely, yeah? And the answer is, if it was the same as 2x plus 4 over x plus 2, then it would be exactly double x plus 2, so that would be good, yeah? And therefore, to make it the same as what it originally was, 2x minus 3, I'll need a minus, what's that, a 7, I think? Yeah, I think that's the same now. And now I can think, okay, 2x plus 4 divided by x plus 2 is just 2. And then I'm going to have minus 7 over x plus 2 dx. And then that's going to go to the answer they've got up there. I hope it's the answer they've got there, 2x minus 7 ln. I'll put it in a modulus like the sensible person at Mad as Maths has done, yeah, and there we go. You can even do it with stuff like this. By the way, this, I don't think I've ever really seen this come up much, apart from on, like, yeah, maybe on a special paper or something like that. Maybe it has come up before, but it doesn't really ring a bell. I've just seen it before, so that's the thing, I've seen it before. You could even do it, really what you're doing here is division, yeah, so you could even do it like on something like this. Let me think, let's put it as over x plus 1, x plus 2, so let's put it over something that definitely factorises. What you could do here is you could write this as, right, okay, as the bottom's x squared plus 3x plus 2, I'm thinking, isn't it a shame that the top is an x squared plus 3x plus 2? So I'm going to write it as x squared plus 3x plus 2. And then I'm going to put minus 6x on the end, yeah? Now, the reason why I've done that is because then I can do something sneaky. I can then go, okay, that's the same as x plus 1, x plus 2 over x plus 1, x plus 2, in other words, 1. What I'm essentially doing here is division, non-division of polynomials, but like in a sneaky way, minus 6x over x plus 1, x plus 2. And then, I don't know if I'll be bothered to go through exactly the last bit of this, but I will describe it. Then what you've got, essentially what we're doing here is partial fractions. You've just got to break this bit now into partial fractions. And if I'm breaking 6x, I will quickly do it. It will probably end up with very ugly numbers though, because I made this up off the top of my head. Equals a over x plus 1 plus b over x plus 2. So 6x is a plus 2. Ax plus 2 plus bx plus 1. You know. But they're never going to make it quite this hard, or if they did, they'd definitely give you some hints. But let me just finish this off. Let x equal minus 2, we're going to get minus 12 equals minus 2 plus 1, which is minus 1b. So b is like 12, is that right? Yeah, looks nice. Let x equal minus 1. If I've made a mistake, I'll be able to check it at the end. This disappears, and this becomes minus 1 plus 2, which is a. This becomes minus 6 equals a. Yeah? Okay, so let me just check that. What we're saying is minus 6 over x plus 1 plus 12 over x plus 2. When you do that times that, you get minus 6x minus 12. That times that, you get 12x plus 12. Minus 6x plus 12x is 6x. Yeah, that's right. Okay, so what have we got here? We could write this then as the minus of that, but that would just change the signs of both of them. So 6 over x plus 1 minus 12 over x plus 2. and then I could go and integrate it, you know. So it doesn't even have to be with linear functions. You could do it with all kinds of functions. But really, there, what you're doing is just long division. Or if you can think of this in other ways as what I describe as a type 3 partial fraction. In other words, a partial fraction which is slightly top heavy, and so you can write it like that. But yeah, so yeah, it's really just partial fractions, but they're calling it a special manipulation. Hope that makes sense. Best of luck with revision. Keep up the hard work, and bye bye.